Hello friends, today I will be discussing LeetCode problem of the day, that is LeetCode 2246. The problem name is longest path with different adjacent character. This is the fifth consecutive question on tree that is LeetCode has given as a problem of the day. So let's quickly start understanding what the problem is trying to say to us. So I will explain you the problem statement. So it is said that you are given a tree which has root at 0. Okay, and you are also given a parent array of length n, where parent p of I denotes parent of node. And one thing is that there are n nodes in the tree. Numbered from 0 to n minus 1, and it is like you are also given a string s and you can say that s of I denotes the character assigned to the ith node. So we can say s of I denotes the problem is similar to the yesterday's problem. You are given a tree. We are given a tree and each node had some characters to it, and the starting node is the 0th index. So I will take an example here. So I will take the first test case of LeetCode itself. So this is your tree and the character associated with it, like A. So our task is to output the longest path of the tree such that the adjacent node doesn't have the same character. So if I say, so these are adjacent nodes, 0 and 1 are adjacent node, and the character corresponding to them are A and B. So we can say that they don't have same characters. That's why this will be a valid part. If you look at 0 and 2, they have adjacent characters same, like A are A, they both have A and they are same. So we can see that this will not form the longest part. So if I say that what will be the longest part in this tree such that the adjacent character are not same, so what will be your answer? Your answer will be like this one, this path 0 1 3. So length will be 3, so you have to just output the length 3. And if you check, we cannot form any path greater than the length of 3. If you take 0 1 4, but you cannot take 0 1 4 because we have 1 and 4 having the same character. Similarly 0 and 2 are having the similar character. We can take this path 2 and 5, but the length will be 2. So this is a valid path, but the length is less than the less than 0 1 3. So this is your problem statement. You have to basically output the longest path having such pair we don't have this like same characters. Okay, so this is your problem statement. I guess the problem statement is clear to you. Now let's move to the approach part, like how you will like approach this problem, or what will be your thinking or the intuition. So let's start with the approach part. You can see I have taken a sample tree. So let me ask a question: what will be the longest path in this tree? uh, like I have taken an assumption here is like that. Let me write the assumption. Each node has a different. Okay, so I'm saying that each node has a different character, so it means like that agency condition that will not follow here, so you can simply ignore that part. So just focus what will the longest part. So if I take this node as the root, okay, this is the 0th node and it will be the root. So what will be the what will be the longest part? So like for this child, the longest part will be this one, right? For this particular child, the longest path will be this one, or you can take this one also, right? Any of these will work because I've already said that each node has a different character. And for this child, the longest path will be this child, not this one. So like for this or like I can reduce this thing to this, like simplify this tree to this part. Let me take the 0th node, and for this child 1, I will call this child 1. Longest path is 2. For child 2, the longest path is 2. For child 3, the longest path is 2. So can you tell me now like what will be the longest part in the tree? I guess this will be 5, because if you go like this, taking this like whole tree, like going from child 1 to node to child 2, you will get 5. Or you can choose like this also. Yes, this child 3. You can either like choose any of this. Child 1 0 to child 2, child 2 0 to child 1, child 2 0 to child 3. Similarly, like multiple cases will there. So like the crux is that the longest part will be 5. So how I came to this and like answer, I took the two longest path of the child. Yeah, I like for this particular route I have taken the two longest path. So this was the longest one, and this was also longest one. I picked two longest path and I joined them, merged them, like I took their sum. So I can write that if I call, let me erase this thing. If I call L1 equals to the longest child path, and L2 equals to the second longest child part. As like in this is a special case, like we all the child are having the same path, so we can say like any one of them can become the longest child path, and anyone can become the second longest child path. Sorry, I got a call in between. So what I was saying that L2, we will call L2 as second longest child path. So for a particular node, if I given the longest child path and the second longest child path, what I can say the longest child path for that particular node will be, let me choose a different color. Longest path for a node will be summation of L1 L2 plus including that node, right? So this will be the longest path for a particular node, given the longest child path and the second longest child path. So for each node, if I calculate this value and I take the maximum of this value for each node, then can I guarantee that I will get the can I say that I will get the longest longest path for the whole tree? Yeah. So that's the like main point. So what I will be going to do is I will be running a DFS, depth first search. You can solve this problem using BFS also, but depth first is I will run a like DFS for each node. I will calculate the longest and second longest path. Like I will monitor. I will like store. Say store longest child path and second longest child path, and at the end I will find the max of or you can say calculate max path length for that node. And thirdly, what I will do, and at last I will up the calculated max path with globalMax. Like I will also maintaining a globalMax variable. So in that variable, what I will be doing, I will just taking the maximum of all the node. Like for one node I calculate the max path, then I will take calculate for the second node from, and I will just compare whichever is maximum I will store in the globalMax. Got it. And at last I will return the longest path. So I'm just returning the longest part to the parent. So like consider this case, this is 0, this is 1, this is 2. So for 2 we had done the calculation, we have taken out the longest and the second longest path, and for like we have to do the calculation for 0, and 2 will return the longest path to 0, and then 0 will perform its calculation and compute its longest path and update the globalMax. So that's how like we are solving this question using DFS. So like a concept of recursion is also used here. So we are just calling for the child nodes, calculating, like getting the longest path from the child nodes, and completing a calculation for the particular node. And one more thing like that confused me a lot in this problem was that this thing, it is said that the tree is undirected graph kind of, but it's not undirected. If you take tree as undirected, like in this question you take an undirected graph, you will like end up really like I was getting that error. But when I like switched to directed graph, when I took directed tree, then like I saw, like I was able to solve this problem. So like let's like I hope like you guys have understood the approach part. Let's move to the like the solution of this problem. Okay. So now let's quickly discuss the solution of this problem. So here I have used the wrapper function provided by LeetCode as the longest path, and the function provide like already give us the parent array or the and the string. So these are like provided by LeetCode. I'm just calculating n, that is the size of the parent. So n will be the number of nodes. So this is number of nodes, and if the number of node is 1, it is like simply return 1. So if there is only one node, you know, like the longest path will be 1. So this is like the simple case. Then I'm like making a vector 2D vector of all the nodes. So like this is for like storing the child for a particular node. Then I'm like creating a globalMax variable. So this will contain our answer, and at last we will be returning this particular thing. Then what I'm doing, I'm mapping over, like I'm running a for loop from first node to the parent, to the size of the parent array, and I'm just pushing back this child to the vector. So let's like take an example, right? It will make more clear. Okay, so I'm starting from the ith index. Why I'm not starting from 0? Because we know that 0 is the root node, so that's why its parent will be -1. So it will be like unnecessary, like it will not be like optimal to store this thing in the map. Like further it will give some indexing error if you do that. That's why I'm starting from first index. And what I'm doing, so this will like mp of it, what it will do, mp of 0 will be 1. Yeah, so what I'm doing, so it is saying that for the first node, the parent is 0. So that's why I'm pushing this 1 to the mp of 0, and it will move further. So it is saying that for the second node the parent is 1. I will push this thing in the first node. So that's why like mp of parent I, push back I. So that is been done here. And then to the last node we will say that mp of So it's saying that for the 0th node we have a child that is like node 1. For the first node we have a child that is node 2. For the second node a child that is node 3. So this is how we are like mapping this. We are doing the like storing the child. Then after that, what I am doing, I am just calling the solve function. That is solving nothing but a simple DFS I have like written. So I'm just calling the solve, passing the like the map, the like child vector, and then the string, the root node, and the globalMax that will contain our answer. In the child node, like I have like taking the reference variable, so it will not take any extra memory in that particular case. Just like the node I'm passing as a pointer variable, or like passing as a value. In the in this solve function, what I'm doing, I'm maintaining the two variable. Like these are for L1 and L2. I already discussed in the approach part L1 and L2. So max length will be L1 and second max length will be the L2. So what I am doing, I'm just calling this I'm just traversing, I'm running a for loop over all the child, and I'm calling the solve function over all the child. So like I'm calling the solve function on all the child of that particular node. I'm just calculating the temporary variable t, and based on the condition, like if the child node and the root doesn't have the same character, then I will proceed further. So that's why I'm written a condition here, like s of, you can see I've written the condition, the character at node should not be equal, or just okay, let me erase this. Should not be equal to char of, or sorry, or you can write this as s of y. So this thing should not be equal, right? So we are moving forward only if this condition holds. So that's like the case. This will like take care that two adjacent node doesn't have the same character, right? Then after doing this, we already calculated the t value, like temporary variable from the child node, and we are checking that if the current stored maximum length is less than the child's, like the child returning length, then what we will do, we have to do an update. So what we will do, we are copy the current maximum length in the second maximum length, and this is doing this thing, and we are just updating the maximum length with the current, like the longest length. So it will like update us, so like it will update our length. So it is saying that now we have the current maximum length, and the second maximum length is stored in this thing, right? So this is how we are updating it. And if like the length given by the child is greater than the second maximum length, so we need to update only the second maximum length, we don't need to update the maximum length. So that's how like I'm updating it. I'm just keeping the track of all the things. So likewise we will like do this thing for the like for all the child of that particular node, and it will give us the maximum length for that particular node. So what I'm doing, I'm just calculating the maximum length here. You can see that this is nothing else but this is L1 plus L2 plus 1. This is what we discussed in the approach part. I'm just calculating it, and I'm taking the max between. Let me make it much clearer to you guys. Okay. I guess this will be much. Okay. Nice. I'm just calculating this part here, and what I'm doing, I'm just taking the maximum of this globalMax and the maximum length. So this will store you this will like update the final answer. So any length, like for any root we are getting, like getting the maximum value, it will be stored in the globalMax. And if other length like other root got the maximum value, we will update the globalMax using like this function. So this function, like maximum function, will guarantee that we are always storing the maximum length in this particular globalMax variable. After that, what I am doing, I told you like I will return the maximum length plus 1 to the parent node. So this value will be transferred to the parent node for its calculation. So like this we are like doing a recursive loop, like we are doing this solution. So like for each node it will call it for children, and the children will call it for children, and the children will return the answer to their parent for further calculation. So that's how like I'm solving this problem. So basically this was a hard problem, like this guessing, like this part was quite hard to guess. I have to take like couple of peep at the official solution, so no issue. You can also like take like hints and all that kind of stuff when you are stuck, but like this problem was quite good. You should try it. And okay, this was my like solution for this problem. And if you had any doubt in understanding anything, you can just write in the comment, or okay, you can just write in the comment. I will try my best to answer this, your doubt. Okay, then bye. Meet you tomorrow with the new LeetCode question.